Let me help transform this text while maintaining its technical essence and making it suitable for narration. I'll use professional office language and explain concepts clearly. Let's explore the concept of access control mechanisms and their implementation in modern systems. The discussion focuses on role-based and rule-based access control, two fundamental approaches to managing system permissions. When considering Group F, users are organized within the specific group designation. The system operates on a principle where permissions are granted at the group level rather than to individual users. For instance, when specific permissions are assigned to Group A, these permissions are only accessible to users who have been explicitly added to that group by an administrator. The practical application of this concept involves temporary group assignments. Consider a scenario where an administrator can temporarily add a user to group for specific tasks, then remove them once those tasks are completed. This approach ensures controlled access management while maintaining system security. From a security and compliance perspective, role-based access control, RBAC, stands out as a recommended methodology for managing resource permissions. This framework provides a structured approach to access management that aligns with industry best practices. Moving to rule-based access control, RULEBAC, this system operates on a different principle. Rather than relying on predefined group memberships, RULEBAC evaluates access permissions in real time based on specific rules. The system examines whether a user meets certain criteria at the moment of access attempt. Subsequently, permission is either granted or denied based on these predefined rules. In practice, RULEBAC finds its primary application in network security components. For instance, firewalls and packet filtering routers commonly implement this approach to control network access and traffic flow. These components evaluate incoming and outgoing traffic against established rules to determine whether to permit or block specific activities. The firewall rule evaluation process follows a sequential pattern where rules are examined in a specific order. While some vendor implementations may have variations, the standard approach involves checking rules consecutively until a match is found. Consider how this process works in practice. When a packet arrives at the firewall, the system initiates its evaluation sequence. The first rule might specify that traffic using IP protocol can proceed if it's destined for a specific destination address using port 80, regardless of its source. If the packet matches these criteria, it's immediately allowed through. In cases where the first rule doesn't match, the system moves to evaluate the second rule. This rule might permit IP traffic directed to a specific server using port 443, again from any source address. Similarly, if a match occurs, the packet proceeds through the firewall. Following this pattern, the third rule evaluation might focus on UDP traffic. This rule could specify that UDP packets can pass if they're targeting a particular server using a designated UDP port, regardless of their origin. To illustrate this concept with a practical example, consider a web server environment. The first rule might allow standard HTTP traffic. The second rule permits HTTPS communications, while subsequent rules handle other specific protocol requirements. The firewall systematically evaluates each packet against these criteria until either a matching rule is found or all rules have been checked. This systematic approach to packet filtering ensures controlled network access while maintaining efficient traffic flow. The sequential evaluation process provides a structured method for implementing security policies and managing network communications. Let's explore how the firewall continues its rule evaluation process, particularly focusing on deny rules and the default security stance. The sequential evaluation includes both permissive and restrictive rules. After the initial allow rules, the system implements specific deny conditions. For instance, the system examines TCP traffic targeting port 53 from any source to any destination. When a packet matches these criteria, it's immediately dropped and no further rule evaluation occurs. This immediate termination of evaluation upon matching a deny rule is a critical security feature. Moving through the sequence, if a packet doesn't match the TCP deny rule, The evaluation continues. The next rule examines IP traffic using port 53, regardless of source or destination. This represents another layer of security control in the rule hierarchy. Significantly, the final rule implements a default deny stance. This critical security principle states that any traffic not explicitly permitted by previous rules is automatically denied. This deny-all approach serves as a security baseline, ensuring that only specifically allowed traffic patterns can traverse the firewall. From a performance perspective, this rule-based access control RULEBAC system demonstrates remarkable efficiency despite its comprehensive evaluation process. The sequential rule checking is optimized for rapid processing, ensuring minimal impact on network performance while maintaining robust security controls. This overview illustrates how RULEBAC implements a balanced approach to network security, combining specific allow and deny rules with a default secure stance. The system's ability to maintain high performance while executing these complex rule evaluations makes it particularly suitable for modern network security requirements.